We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle Compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann Parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
John, how can you always have the right TV for the right application without carrying hundreds of valves on your truck?
You can carry the hundreds of valves on a trailer behind your truck.
That's too funny. That would work, but how are you going to do that? Maybe there's an easier way.
You can use Sporlan's interchangeable cartridge style Type Q and Type BQ TEVs. Type Q is a conventional design and Type BQ is a balanced port TEV.
Well, come on, I need easy. How easy is it?
Easy as 1, 2, 3.
And it serves thousands of unique applications. So what's the process? How do I put this together?
First, you select the thermostatic element assembly. Then you select the body that you need. Then you select the right size cartridge for the application to get the proper capacity TEV for your application. And then I guess it should also be said you want to actually assemble those into a single valve.
That'd probably be a good idea.
Indeed.
These easy to select and assemble valves mean you're always carrying the right valve for the right job then. If folks want to learn more, what do they do?
You can go to sporlan.com and find more information on the Type Q and BQ thermostatic expansion valves.
I guess that's Jim and John for Sporlan signing off.
Hello, everybody, and welcome to Advanced Refrigeration Podcast. Here with your hosts, Brett Wetzel and Kevin Compass. What's going on, man?
Oh, just enjoying the week. Trying to get over this nasty cold that is literally killing me.
How was your turkey day?
Wasn't bad. I mean, small little get together. How about you?
Same. We usually just, I don't know, so we don't have to do so much cleanup. We usually get something from like Sprouts or something where the turkey and everything's like kind of pre-made and we just have to heat everything up. And we'll get appetizers, frozen appetizers, and just snack out all day just to be even fatter and,
Yeah, I'm not a big turkey. I'm not a big Thanksgiving fan.
Yeah. I am just not feeling the weeks of leftovers.
All right, guys. Well, today wanted to go into and talk about low load situations when it's cold, how to deal with them, how to make it work in your favor, and how to keep the rack running. So, with that being said, we had a lot of situations up here last week where we were in like the low teens, almost negatives, with the outside air. So we had a lot of racks crashing. Not so much, racks that were properly sized and fully loaded. I'm talking like smaller racks, racks with not a lot of load, racks where they've had cases changed out from, energy hogs to, high efficiency cases, and we lost a lot of load. So, we had a lot of issues that arose and popped up from this. So I want to go over today on how to deal with this, how to identify the real issues, and how to make it work in your favor. So, a couple things. So, these particular racks, they were, a little neglected. I mean, there were some issues, some stuff that should have, been PM'd on them. But for the most part, a lot of it was cycling issues. So, or oil issues. So, what we ended up doing with this is, so if we give an example, the first one, this rack has kept going down nonstop. It kept flooding out. Everybody would go there. It would be flooded out. They would get there. They get all the liquid out of the rack. They couldn't find any flood back while they got everything back going. Fast forward, sun would go down, rack would flood out again. And every night it was doing it. It was flooding out every night. So come to find out, after I got on site and started looking at stuff, the EPRs were cycling nonstop, all of them. So every one of the cases, the EPRs were wide open, and they were running on temperature defrost strategy instead of on the EPR like they should have. Now, a lot of guys like to run the temperature defrost strategy. I am completely opposed to it. I'd rather than just run on EPRs or a CDS valve. I don't like the controller doing it. I guess as a backup, but the problem is you end up getting this terrible cycling going on. And when you start cycling, cases off, it's never good. Well, another company had this store before, and they were opening up EPRs, to hide problems with cases. So case run a little warm, open EPR a little bit. Case runs a little bit warm, open EPR a little bit. Well, after a long time, when you start doing this, next thing you know, as soon as you hit wintertime and you start getting boatloads of subcooling, those problems with the valves not feeding properly, those valves start feeding better because they have better liquid. And next thing you know, you have cases making temp and shutting off. So when they start shutting off, you get this horrendous, loading and unloading of the rack, especially when you have, 4 or 5 cases that are, way above your suction saturated temp, and they're making temp right away. And then that rack is just, it can't react fast enough.
I think that's why Kevin and I are big proponents on making sure the rack is working right first. A lot of people, they'll jump right to the case, because it's a case issue. It has to be a case issue. Not necessarily. I mean, it could be the EPR is set too low. It could be that the EPR is set too high. The expansion valve is set too low or whatever. But I mean, you won't really, sometimes going back to the rack first and getting everything running right, like within spec first, is the best thing to do, because then everything is working right with the rack, which might resolve other issues down the line as well.
Yeah, I am a huge proponent at making sure the rack is 100% right first. And like here lately, I've been, when I'm checking some stores we've taken over, the first thing I'll do is I'll go to the EPRs and I'll listen for a few minutes to see if they're cycling, and then I'll check the stems. If you got stems that are real loose, or you could see on the stems, like a Sort 12, for example, those aluminum bolts in there, you could usually see, or the stainless bolts, you could usually see the line on them where they were for the longest time. So you could see if somebody's opened them up and messed with them. So that's one thing. Like, say you're, for example, you're at a Walmart and you have Novar. Novar runs off the B case. So older Novar, for example, runs off the B case. So whatever the B case is doing is how it's going to control your actual EPR load. So if that B case makes temperature, that's all the controller cares about. Does it care about A, C, or D? It only cares about the B case. That's how the older Spectrum controllers are programmed. Now, they have a cut in and cut out set point. So say your cut out set point is 30 degrees and your cut in set point is 34 degrees. Now you want to be in the middle of that. Your set point, actual set point, is dead nuts in the middle. So 32 degrees would be your actual target temp. So don't go by the legends on the door for the most part, because most of the time the legends on the door aren't the set points they're trying to run. So you need to go in the middle of the cut in and cut out set points if you're running older Novar. So if it's like, for example, again, if it's, a 26 degree cut out and a 29 degree cut in, you're going to be 1.5 degrees in between cut in and cut out is going to be your target temperature you want to maintain with that EPR. Now that keeps you out of alarm on IMS side of things, meaning like it's not going to tag you for a case that's in a warning, and then it's not going to cycle. It gives you enough leeway where it's not going to cycle. Because if you start cycling on some of these older racks on older Novar, you're going to spool up the controller and it will not react fast enough. You want to keep the actual rack running in the neutral zone, meaning before it stages up and before it stages down. So you'll have a cut in and cut out for the compressors on Novar. So say it's 46 pounds cut out and then 53 cut in. As long as you stay in that neutral zone, it's not going to stage up. So that keeps you from short cycling compressors. And then same thing with CPC. If you stay in that deadband zone, you're going to be a lot better off. You're not going to start short cycling compressors. When you start bringing loads on and off rapidly from EPR cycling, that's when you start spooling up the compressors. And next thing you know, it brings a big compressor on, sucks the suction down real low, all the EPRs close down, and then the rack just shuts off.
And then you have this vicious thing where the rack just keeps short cycling itself to death. You'll see high cycle counts. You might even see oil issues because a lot of these oil separators were meant to be loaded up all the way. If you're shutting off EPRs, that's not going to happen because now you're essentially going to be running maybe only half the rack capacity that was intended for, which might, if you have a centrifugal or helical separator, will end up causing oil issues because those ones are dependent on discharge CFM. If you don't have the right discharge CFM, once you go, I think 80 or 85% of the actual load, if you go any lower than that, the oil separation rate sucks, and then you won't actually separate the oil. So you'll get there and you'll find that you'll have no oil in the separator, no oil in the reservoir, barely any oil in the compressors. And, usually to test that theory, I'll usually shut down the rack for, probably about an hour, 45 minutes, basically shut down the whole liquid line, so we're not, getting any suction, liquid back or whatever, and then letting everything warm up. And then once I do that, I open the cases back up and you'll see a abundant amount of oil come back through the suction, which then will start filling up the compressors, which then will actually start separating on the oil separator, because now you have the proper flow going through that oil separator as far as the helical. You don't really have to worry about that on centrifugals, or I'm sorry, you don't have to worry about that on coalescing because, if it's rated for 35 discharge CFM, it can go as low as 2 discharge CFM. So they have a wider operating range because it's essentially a filter that's filtering out the oil rather than relying on the flow.
Just not the other way with those. I learned that the hard way. You just can't overload a centrifugal, or not a centrifugal, a coalescent, because it'll actually push so hard through there, it'll actually not separate any oil.
I'm assuming that's probably why we had those issues on that CO2 rack that I was telling you about, where the HPV wasn't closing down. And because that wasn't closing down, you just had all this flow going out, and essentially it was over pressurizing the flash tank as well, because it wasn't designed for that much load to come back. Just caused a whole bunch of oil issues.
Yeah, I mean, so oil issues you're going to have. The other thing I want to talk about is if the rack does shut off and it's a medium temp rack, we had this particular problem at the store we were at. The rack would shut off and it would take like 5-10 minutes sometimes for it to come back on if it did. So if it's cold enough and this thing shuts off, it may not restart on its own. Especially if it's in the negatives, there's a pretty good chance your plus 18 rack's not going to restart on its own. So especially if it logs all the gas up in the condenser, I mean, you may be done until you get on site and you force this thing to restart. Now, the problem we had was it would shut off, and we were actually condensing into the suction header and the accumulator and the oil reservoir. We were turning it into a liquid, so it was sitting off, and it was so cold outside that we were condensing, and everything would come back to as soon as the rack would start back up, the compressors would start drinking liquid. So that was the big problem we had, is we were condensing inside the suction header and the accumulator and the oil reservoir because it was so cold, and it was a small porta pack rack, and it was just wind blowing up from the, hitting the bottom of the roof and coming right up inside the rack, and it had nowhere for it to go. So there's no heat generated in there because you have no discharge heat, because we're running such low load already that it had no way to overcome and boil off that liquid. And those crankcases weren't warm enough because those crankcase heaters aren't doing much when they're out in the cold like that. So it ended up flooding out the compressors to the point where somebody would have to come there and pump the liquid out of them because they were hydrolocking.
Yeah, I just heard about that the other week. Someone had said something about that the compressor won't start. I was like, well, did you try flipping the rotation? He's like, yeah, but all the compressors are doing. I'm like, then you have lots of liquid or something preventing. I mean, the chances of having all the compressors off on lock rotor, unless you have a phase loss, is very on high probability, right?
Oh yeah, I mean, it's going to be pretty rare for that to happen. But I mean, it for us, it really it was a real odd situation. So we ended up going through the rack, and we ended up setting all the EPRs. So going through each one, setting them to what the OEM spec was, started there, and then watched them. They were still cycling off. So we raised them up some more. Then cases started not making temp. Then it's okay. We go downstairs, and it's like case A is at 31 degrees. Case B is at 36. Case C is at like 34. All right. Well, now it becomes a problem. Okay. The rack's running, but now we got all these case temp issues because we set all the EPRs. So now we got to figure out the real problem here. It ended up being like 4 fan motors out in this lineup, 2 fan motors out in this lineup. Fan plenum's not all the way down. Somebody went around and just slammed open a bunch of Danfoss valves.
Yeah, sometimes other low load situations that they can come awry that and it's a construction thing that actually causes it, but then you don't notice it because there was no preparations taken. Is when they put doors on the medium temp cases that didn't have them before, because I think we looked up. I think it cuts off about 65% of the actual load on the case. I think it's only 35% of what the original load is. So it caused the compressors to short cycle because there was no, besides regular unloading, there wasn't anything to get down low enough to be able to control that pressure, because now you basically reduced the load on that rack by a shit ton, depending on how many cases that you did, right?
Yeah, those racks, I hope to God that I never see one on the roof done like that, because I mean, that would just be an absolute disaster waiting to happen, especially in the cold. Like if you just threw some glass doors on there and it seems like nobody ever pays attention to the compressor side of things, that would not be good.
Yeah, no, I've like I said, I think I've seen 1 or 2 systems like that where I've seen it actually happen, where they didn't prepare for it, as far as on the actual operation of the rack, and then ended up causing a shit ton of service issues. And we had to basically figure out, well, what changed? Well, they put doors on, and you'd see a whole bunch of CDS valves going down to 0%, when you could try, if you're available to float your suction a little bit, to have the expansion valves open up a little bit more and make your cases basically run a little bit harder than what they would. And so you don't have that cycling, because we want to keep those compressors running. I mean, we don't want, most of the time they say 240 cycles is the max you want to go through in a day. And I agree, but I mean, even 240 is a lot, right?
Shoot, I don't want to see it over 100.
No, and I agree. I mean, it'll help the longevity of the rack. But what I'm saying is, as far as max wise, which is weird because, in most books, it is written that it's 10 cycles per hour. But if you look at like a contactor manufacturer, they'll say 6. So who's right? Is it the contactor manufacturer or is it the actual compressor manufacturer? Hello, guys. This episode is brought to you by Fieldpiece. The tough wireless vacuum gauge MG44 from Fieldpiece is engineered to give you the reliable reading you need and the ease that you want. Confidently measure vacuums with a reliable leak-proof seal. The MG44 can be used with the JobLink system app from up to 1,000 feet away. This easy-to-read backlit LCD offers a graphical representation of the vacuum progress, even in low light or at odd angles. Visit www.fieldpiece.com for information or follow us on social media at Fieldpiece Products. Thanks again and enjoy the episode. Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode.
Yeah, they're both just going to point fingers at each other when it fails anyway.
Agreed.
Yeah. So that the other thing is, guys, with when you're dealing with low load situations on racks, I see this all the time. Guys want to run the suction pressure down thinking that it's going to make the rack run more. That is completely false. All you are doing by doing that is making the problem worse. Yes, it'll run the rack for a few more minutes, but when you lower the saturated suction temperature, think about what you're doing. You're lowering all the pressure. Okay, so now what are those EPRs going to do? They're going to clamp down more because those EPRs are going to be less open because they're trying to maintain a set suction saturation pressure. So they're going to be less open. So they're going to clamp down, and then you're going to reduce the flow to the rack even more. So lowering the suction pressure makes the problem worse. What you want to do is you want to raise the suction pressure. So by raising the suction saturation pressure, you're going to cause the EPRs to all open. The more open you get these EPRs, you want them set to where the cases aren't going to cycle and they're going to maintain temp. But the more open you get these EPRs, the better off you're going to be. That's why floating suction pressure in low ambient conditions is a must. Because if you float that suction saturation pressure up a few pounds and you get that rack running a little warmer, then what it's going to do is it's going to open all those EPRs. You're going to have a more constant load. So the more constant load means you're going to have less compressor cycling because you're going to be in that range where it's just going to be a constant load. And then you may just maintain, maybe be a pound or two under or over with just that compressor running or whatever compressor's running instead of cycling in between pumps.
Now, this is my theory on now that I agree with that 100%. But as far as if you float the head lower, my theory is that it's basically going to make the expansion valves look smaller So it's going to want to load up the valve even more and open it up wider. I had that happen on someone was doing a remodel in a store, and they called me up because they said they were condensing. They had such a low load situation because they were doing a retrofit or something, and they were moving cases off of it. So his load was barely nothing. So he ended up raising the head pressure to, raise the temperature in the separator, which is a fine idea in theory. But if you don't have the load to keep the compressors running, it's a shit idea. So he looked at all his electronic expansion valves, and he was running at, I think, 3% or 2% for electronic expansion valves. So I said lower the head pressure even more. Like, he had it up to back up to 95 degrees saturated. I said, dude, run it down to like 60 or 65 and see what happens. And all of a sudden he had more compressors kick on because he had the expansion valves open up more, which increased the load going back to the suction. And the flooding, or what he thought was flooding, it was, basically oil condensing in the separator because he didn't have the heat for it, basically went away because now he had a more constant load. So now instead of running a compressor for like 30 seconds and then shutting off, he was running that compressor nonstop.
Yeah, we had a 513 rack. It was a everybody's favorite bullseye store, and it was an addition, like a C D rack, but it was only the C. I was the D rack, and what they actually did is they put like 40-foot of multi decks on this thing, beer cooler, and a random coffin case. So it's running 513A, and it had a Bitzer Verispeed. And every one of the cases, every 12-footer was its own case. So you had a bunch of overlapping defrost now because you had a bunch of cases that had 8 defrosts a day because they were Hill NRG cases. So go ahead, Brett.
No, I'm listening.
So they were a bunch of Hill NRG cases. So it was 8 to 12 defrosts a day. So no matter what you do, you're going to have overlapping defrosts. And what this thing was doing, it had a bitch of Verispeed. When the Verispeed was running unloaded, it wouldn't make enough heat. So if it was running like 25% or 25 hertz, the discharge line was barely getting above like 80, 70 degrees. So when it was like 20 degrees, 15 degrees outside, we were condensing inside of the separator, and it would just feed liquid into the compressors and grenade them.
Wow.
We blew up this Verispeed probably 6 times before Hill Phoenix let me repipe the suction. And then we ended up putting heat tape on the oil separator.
Yeah.
Because we couldn't keep the oil separator hot enough. Because there's just no load in the store. We got a bunch of NRG cases running 34 degrees.
Yeah, we had a similar issue on a Cascade rack, but basically they have a D superheater, and on this one, you can use many types of D superheating, right? You could use a 3-way valve going to a loop in the condenser. You could do an external coil, which is what they did, which is fine, and it had dampers, so you'd think theoretically it should shut off the air. Well, not when you get that nice, northeast wind where the air is basically going through the D superheater and then making the D superheater essentially into a condenser. So what would happen is the temperature of the CO2 going into the heat exchangers was like 30, 35 degrees. And because now you're basically a liquid, the heat exchangers are not loaded up at all. So your valves are going to go to 0% on your heat exchangers that do the cascading. And they'll end up flooding back on the cascade side, but actually go off on high vessel pressure on the CO2 low temp side. And that's because you've essentially become vapor locked at one point because there's no kind of bleed off. And yeah, you end up having a real bad time. So we actually installed a bypass around the D superheater. Whenever we get down to a certain temperature, it would lop off the refrigerant going to the heat exchangers, and that was it. We basically stopped the D superheater from being an external condenser, and it actually fixed the problem because we were blowing out a lot of compressors too because it was shut off on high vessel pressure, and it would still try to feed because it's still on high pressure, and it would just feed everything, the liquid header or the suction header, up with liquid.
It's amazing how efficient, like, especially with like CO2, a small coil like that can be when the temp is low. Like, I mean, you pretty much could almost do that rack with that coil, probably.
Almost, yeah. I mean, if it's cold enough outside, yeah, for sure.
Especially up here up north, like we have one of those stores, and I was thinking the other day, man, they stuck like a little 2-fan, little gas cooler up here. They probably could run the whole rack, the low temp rack, off that instead of on the medium temp. But
Yeah, at first we thought it was like tuning issues. It had SMS controllers on there, so we ripped them out and put on in the yeah, we ripped them out and put in the Sporlan Super E controller, because that's basically all it's controlling. And I tuned for whatever until we figured out really what the main problem was. I mean, those SMS controllers, they're kind of janky as far as like PID control. Plus, you have to have a 40-year-old program in order to communicate with it, and it's just not fun. Plus, you'd have to have a laptop every single time you went out to diagnose. Not every single technician has a laptop.
I have never been able to get that thing to work on my computer. No matter what computer I have, I can't ever get the dongle to work.
No, we got it working. It's just, the lights are kind of ambiguous. You know what I mean? It'll just say high superheat or low superheat, but we don't know if you don't know what the hell it's reading until you actually communicate with the actual controller. And that's the bitch, right? You'd have to actually measure your resistance of the sensor to try to figure out where it's off. You know what I mean? And same thing with the pressure transducer. You have to measure the voltage coming back to see if that's right versus what it should be as far as the range.
Just a heads up, guys, that all those the transducers and temp sensors are just Sporlan ones. So you could literally just take a Kelvin and slap it right on there. They're all the same transducers and temp sensors. They're all Sporlan ones. So if you do have an SMS go bad, you can just go get a Kelvin 2 controller and slap it in there.
Yeah, I saw someone post something on there that was like, "Hey, what do you use for that?" And I was like, "Yeah, rip it out and put in a Sporlan Superheat controller," because, like you said, it's made by Sporlan. That SMS controller, even though it's a Hillphoenix product, it's still made by Sporlan.
Yeah, I mean, I don't think you could buy it though. Can you
No.
even buy those things anymore?
That I don't know, because like I said, my answer is typically, as far as serviceability, rip it out and put in a Sporlan Superheat controller.
I'm not gonna mess with the thing. It's getting a Q body or a Sporlan Super E controller. So back to the low load thing, guys. So like we said, getting that suction pressure up so you can get these EPRs opened is a must. And then another thing I want to go over is if you are running like sort 12s or 15s or 20s or whatever they are, and you have a pilot driven EPR source, make sure that the pilot line pressure is high enough. If the pilot line pressure is not high enough, then you're not going to be able to get those valves to close off more or close off enough. We had this at another rack where somebody had messed around with the crankcase pressure regulator that's feeding the outlet to the outlet pressure to the pilot lines. So the outlet pressure to the pilot lines is supposed to be like, I don't know, like $120, maybe 130. You want to keep it, high enough where you're going to defrost cases and shut for that, but you're also want to keep it so it's not too high and you're wasting pressure feeding into the suction header for the vents on the pilot valves. Go ahead, Brett.
It's also good to make sure, sometimes you'll see there's no liquid actually coming back from the case, but you'll see the line that from the pilot assembly that, purges off whatever pressure that you're using back into the suction. You'll see that line ice up. A lot of the times that will be because whatever line is your pilot line might be condensing liquid in there. Prime example, sometimes you'll have a rack that's a loop system, but it also, on the medium temp, it also does the subcooler. And you'll see where it looks like it's flooding back, on the outlet of the valve going back to the rack. And it's not technically flooding out. You're just getting a little bit of liquid that's forming in there because, they have a 7/8 line that feeds a little 3/8 line that goes to the 1/4 inch of the valve. and that's basically because it's just sitting there and ends up condensing. Because you might be at discharge pressure, which, for all argument's sake, let's just say it's 100 degrees saturated, but the line's been sitting there in a motor room that's 78 degrees. Well, 78 minus 100 is, X amount of degrees of subcooling. So, you basically are feeding that valve liquid, which is not good either. That's why it's good to go on the lower side of the adjustment to make sure that in your colder climates, racks that are outside, racks that are, especially on the roofs, that you have that pressure able to be lower, and for that you'd use an outlet pressure regulator. So you could use essentially a crankcase pressure regulator that's rated for that pressure. An A9 you could probably use for that as well, depending on how much flow you need.
Oh, I muted myself.
No, you're fine.
Yeah. So the frosting, I see that way more on the Husband racks where they're using vapor from the top of the receiver. When those seem to do it a lot when they're pulling vapor off the top of the receiver instead of using discharge gas. And sometimes that can cause kind of sluggish regulation. So, I mean, we've had a couple racks where it was causing problems that we ended up repiping it and bringing the vapor off for the vapor from the top of the receiver, ended up capping it off and bringing it off the discharge line. So that way it wasn't condensing. Did I freeze?
No, I'm just thinking of anything else to talk about.
Oh. And then lastly, okay, guys, if you do have a stalled out rack, meaning like it's down and it's not restarting, let's go over this real quick. So the
Sure.
quickest and easiest way to start this up, say the rack's on the roof and you got a rack on the roof, it's stalled out, all the liquid is sitting in the condenser and in the receiver, and you got to try to get this thing back going. Well, it's not going to restart on its own. So this is the easiest way I have found to do it. What I will do is I will shut the discharge lines going to the condensers. So I will shut the condenser ball valves off. Okay. I will force a compressor on, and I will make sure the line going to the ORD valve or the A9 valve, whatever is pressurizing the receiver. So I will make sure that that line is open. Okay. And what I'm going to do is, what we're going to do by shutting off the discharge ball valves is we're going to make it so we can build up pressure in the compressors and pressure and heat. And then we're going to force all that pressure into that receiver. And whatever liquid is sitting in that receiver, it's cold. Remember, it's not going to want to move. So whatever liquid pressure and temperature is sitting in that receiver is now going to get hit with that from that 5/8 or half-inch line. It's going to get pressurized with high pressure vapor, and it's going to cause that liquid to warm up and want to move, and it's going to push it all downstairs. Once you get that liquid downstairs, you're golden, because now you're going to start refrigerating and you're going to start boiling off, which is going to make suction pressure. So once it starts spooling the rack up and you get a little bit more flow and a little bit more compressors coming on and your head pressure starts getting up around 200 pounds, crack open the discharge and then force all that liquid out of the condenser. And then once you do that, that rack should take off and start on its own. And then you need to figure out why it went down. Did it go down because you don't have your winter controls set properly? Or did it go down because you're having issues with EPR cycling and you have no load, or your suction pressure is too low? Or did it go down because you have oil issues? So you need to figure that out. I mean, they could all be hidden in each other. You could have oil issues masked as low load issues, or oil issues masked as, cycling issues. You're losing, oil flow, or it's, because of cycling issues. It's not actually an oil separator issue. It's just the fact that you're cycling like crap, or you're flooding out because you have, case issues, or the store is too cold. I had one the other day. The store was 54 degrees. So all the racks had no load.
That's kind of ridiculous.
Yeah. And nobody said a word. Nobody said a word. They're all in there in sweatshirts. And I'm like, it's 54 degrees in here. Oh, well, yeah, we had a couple customers complain, but I mean, okay, it's 54 degrees. Like, what are you doing?
Yeah. That's
So
kinda
we
dumb.
ended up, as soon as you get the heat going, I mean, the racks just started staging back up. So, I mean, that's another thing. I mean, you guys got to keep the heat in these stores, and especially like we have, like all these. We can't run nightshades in a lot of these stores when it's super cold outside because there's no load in the store. So, I mean, if they pull the nightshades down, you're cutting the load in the cases by 40%, 30%, depending on the case manufacturer. So that nightshade may be screwing you and, taking off what little load you had. So you may have to keep the nightshades, open, to get you through the night when it's really cold like that. But I mean, just making sure you have, constant flow. And then, low pressure oil systems, we've had this a lot, and I want to talk about this. So if you have a low pressure oil system and you have a reservoir and you're outside and you don't have a lot of oil flow, meaning your compressors aren't using a lot of oil, and you say you're just running one compressor, maybe two compressors on occasion, you got real low load. So what ends up happening is that oil sitting in that oil reservoir will condense and you'll lose pressure, and not through the OCV. The OCV you'll be fine, but you'll actually lose pressure as that vessel gets colder. Think of it like a drum of refrigerant. As it gets colder, it's going to lose pressure. So that actual oil reservoir does the same thing. So I've seen guys condemn an OCV when an OCV is fine because there's no pressure in the oil reservoir. Well, the oil separator is working. It's just not cycling that much because there's not a lot of oil movement. So they'll either get liquid in the oil separator or liquid or in the oil reservoir. They'll get liquid in it, or it'll turn to liquid because it's just sitting there. It has vapor refrigerant in there. It gets cold enough, it'll condense. So if you don't have constant flow from the oil separator, dumping discharge gas in there with the oil, superheated oil, it's not going to keep it from condensing. So we've had a couple of issues that we've had come across with this, and we've had a couple fixes we do. So there's one fix we do when it's super, super cold out. And on a couple of these racks, usually the Hill Phoenix like pack racks, is we'll take a line off a compressor, usually number one compressor, right off a discharge service valve. We'll take a ultra tube and we'll dump it in the top of the oil reservoir. What this does is it allows that oil reservoir to constantly have discharge gas flowing into it and being pumped out the OCV. So this does two things. It allows the oil reservoir to constantly have pressure in it. So if we need oil, it's going to fill, and it helps keep it warm so that it always has discharge gas flowing in there and being pumped out from the OCV. So that'll keep you from condensing, and it'll keep you from losing pressure. So that's one thing that we've done. That's not something you want to leave permanently. That's like when it's like -5 outside and you have issues with these racks and you need to keep it running. That's what you do. The other thing is wrapping the oil reservoirs in heat tape and insulating them. There's a ton of them in Chicago like this on outside racks. We ended up wrapping them in heat tape and insulating them, and then putting a thermostat on there for like 20 or 30 degrees above saturation. So if you're running like a plus 20 rack, we're trying to maintain the oil reservoir at plus 40, plus 50 degrees just to keep it warm enough. That way you have warm oil going in there. Me personally, I like to see it. I'll cut it out at like 85 or 90 because you want that warm oil going in those crankcases. Cold oil doesn't flow, especially when you start to get the thicker oils. Like you start getting in like RL68 for like the Carlisles, it starts getting thick. When you get the CO2 and it's 85 weight, I mean, it's even harder. Or the screws where it's 120. I mean, that stuff turns to molasses when it's cold. So it doesn't want to move into this compressors. So the warmer you keep that oil, the better you're going to be.
I totally agree. And with that said, I think we're at the end of this episode, and we'll see you next time.
All right, guys, have a nice one.
Bye bye.